We define a custom annotation at GenerateBuilder. It is retained only in source code, source, meaning it disappears after compilation, no runtime overhead. It targets classes, type. When the compiler sees this annotation on a class, our processor will kick in and generate a corresponding builder class. This is the entry point for compile-time code generation. The processor is a class that extends abstract processor. Two important annotations on it at supported annotation types, builder.generateBuilder, tells the compiler which annotations we handle, at supported source version.release_17, indicates the Java version we support. The compiler will instantiate this processor and call its process method during compilation. Process is the heart. We iterate over the annotations we're interested in, only one, in our case. For each annotation, we get all elements annotated with it. We check that each is indeed a class, if not, we print an error using processing.env.getMessager. For valid classes, we call GenerateBuilder. Returning true means we've handled these annotations, no further processors needed. We extract the package name and simple class name. The generated builder will be named builder. We then obtain all instance fields of the class using the element API. We filter the class's enclosed elements for fields that are not static. We collect them into a list. If no fields are found, we issue a warning and exit. We use processing.env.getFiler.createSourceFile to create a new Java source file with the builder's fully qualified name. Then we open a print writer and start writing. The package declaration, if not empty, an import, will include java.util objects just in case, though not strictly needed, and the public class declaration. For each field, we declare a corresponding private member in the builder. Then we generate a setter method, e.g. that takes the same type, assigns the value, and returns this for fluent chaining. The method name capitalizes the first letter of the field name. All of this is pure string concatenation. A simple person class with 3 fields, getters/setters, and a noart constructor. By annotating it with @GenerateBuilder, we instruct the processor to generate a person builder class. This is how code generation is triggered, simply adding an annotation. After compilation, we can use person builder as if we had written it by hand. The Fluent interface creates a person object. This shows the end result of the code generation, compile-time metaprogramming that reduces boilerplate. The build succeeds because personBuilder.java was generated during the second compilation step. You've just built a real compile-time annotation processor, the same technology that powers Lombok, Dagger, and MapStruct. Understanding this opens up a world of metaprogramming. You can generate repetitive code, validate constraints at build time, and create frameworks that feel like magic but are completely transparent. Now you can write your own code generators for any project.